Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing KVPY 2018 SX Part 1 Mathematics, and the question for this video is this. Let there be function f whose domain is -1 closed to 1 closed and codomain is all real values. Be a function defined by f of x is equal to x square mod cos of pi by x for x not equal to 0 and 0 for x equal to 0. The set of points where f is not differentiable is 4 options. So basically we have to comment upon all the values of x at which f of x is not differentiable. Let's do it. So what would be my suspicious points? The values of x at which the function can possibly be non-differentiable. First of all, very rightly so, since the definition of fx is breaking at x equal to 0, one of the suspicious points would be x equal to 0. And other suspicious points would essentially be all the values of x at which cos of pi by x is becoming 0. Because from our experience with the functions and the graphs, mod x, although continuous at x equal to 0, is non-differentiable at x equal to 0. Why? Because at that for that value of x, it is becoming 0. So similarly, all the values of x at which cos of pi by x is becoming 0 would be my suspicious points. And what would those points be? Cos theta becomes 0 when theta is odd integral multiple of pi by 2. So here I can say theta is pi by x. So x essentially you may say is of the form 2 by 2n plus 1, where n is some integer. So let's first check whether the function is differentiable or not at x equal to 0. So here f of 0 is anyway 0. So f prime 0, if at all it exists, would be what? Limit x tending to 0, f of x, which is x square mod cos pi by x, minus f of 0, which is 0, divided by x minus 0. So essentially divided by x. Now if you see carefully, this x is tending to 0. And what about this mod of cos pi by x? As x approaches 0, pi by x, at x equal to 0, pi by x is not defined. The point is, as x approaches 0, either from left or right, that means either from negative side or positive side, cos pi by x will oscillate between -1 and 1. In fact, mod cos pi x will, oscillate between 0 and 1, which is, which are finite values. So something tending to 0 multiplied by something which is finite. So that means the limiting value is 0. So that means f prime 0, using this first principle, so to speak, we are getting its value to be 0, which is finite, which is acceptable. So that means f is differentiable at x equal to 0. So x equal to 0 would definitely not be my answer. Now here A is surely incorrect. Why? Because x equal to 0 is one of my suspicious points. And A option goes to say function is differentiable or function is not differentiable everywhere except x equal to 0. In this interval -1 close to 1 close. No, it's wrong. Why? Because I have only two types of suspicious points, x equal to 0, at which function turns out to be differentiable, and x equal to 2 by 2n plus 1, where n is integer. So now let's explore this. Here, first of all, when we talk about x equal to 2 by 2n plus 1, if you see carefully, limit x tending to 2 by 2n plus 1 f of x is same as f of 2 by 2n plus 1. You can very easily understand this. Why? Because, limiting value and the functional value both would be 0. Functional value is 0. Why? Because cos of pi by 2 by 2n plus 1, essentially it becomes cos of odd integral multiple of pi by 2. Odd integral multiple of pi by 2 ka cosine would be 0. So functional value is 0 like this. And as far as limit goes, as you apply limit, this expression, or let me use this, this expression tends to 0, and this expression goes for something finite. So something finite multiplied by 0 is 0. So limiting value is equal to functional value. That essentially means f of x is for sure continuous at all these values of x, which is 2 by 2n plus 1, where n belongs to integer. Now to comment upon left-hand derivative and right-hand derivative of fx at these values of x, given that fx is continuous at these values of x, we may directly consider the expressions in those neighborhood of these points x equal to 2 by 2n plus 1 and differentiate them to comment upon left-hand derivative and right-hand derivative. We know wherever cos theta becomes 0, in neighborhood of it, on one side it is becoming, or on one side of it is positive, on other side of it it's negative. So what we can say is, around x equal to 2 by 2n plus 1, on one side this f of x expression would be x square cos of pi by x, and on other side it will be minus x square cos of pi by x. Because again, in one side of neighborhood, this cos will be positive, so this mod will open with plus sign, or you may say this expression will come out of mod with plus sign. And for other side of neighborhood, this expression would come out of mod with minus sign. So in one side the derivative would be, you may say 2x cos of pi by x, x square, cos pi by x derivative will be minus sine pi by x multiplied by minus 1 by x square. So this cancels out. So this essentially becomes 2x cos pi by x plus sine pi by x. And similarly here the derivative would be what? 2x cos, minus 2x cos pi by x minus sine pi by x. Now one side derivative would be having this expression, another side derivative would be having this expression, and as you put x tending to 2 by 2n plus 1, this expression, or let me show it this way, this expression in both cases would become 0, because cos term would become 0, and these two expressions would be of opposite sign. In fact, input to sine is being odd integral multiple of pi by 2. So it will either be 1 or minus 1. Now if it is 1 here, it will be minus 1 here. Why? Because if this is 1, so minus times 1 is minus 1. And if this is minus 1, then minus of minus 1 becomes plus 1. And anyway, these two terms are in respective parts are 0, because cos of odd integral multiple of pi by 2 is 0. So here, so that means the derivatives, left-hand derivative and right-hand derivative, would be 1, minus 1, or minus 1, 1 respectively. They will not be equal. In fact, you may say there will be a kink point. There will be sharp corner, so to speak. So that means at all these points, x equal to 2 by 2n plus 1, where n belongs to integer, f of x is not differentiable. So here, C is my answer. Thanks for listening. Stay tuned for the next question.